Welcome to another lecture of our automata playlist. Today we will learn about the conversion of regular grammar, regular expression and DFAs. So I will create first the regular grammar for this particular automata or DFA. So there the initial state is Q1. Okay. So for Q1 I will write S. This is the for the start state. Okay. I will write the start variable S. So what are the inputs from Q1? That are A and B, and where they are going for each of them. So from Q1 for input B, it is going to Q2. Okay, so I will write this Q2 state as suppose I will write this as A. Okay, so for input B we are going to A, and for input A we are going to another different state, so I will write this next state as B. So I will just add these things as pipe operator. So for input A from state S, for input A it is going to state B. Okay, so I will just write it here. Okay, this is the state S, this is the state A, and this is the state B, and this is the final state. So I will write it like F. So from here for input B it is going to state A, and for input A it is going to state B. So I have written it like this. And also none of these are final states, so it will not become this particular only terminal points will not be here. And now what are the states from A we can go? So see, from state A, if it takes input A it will go to B. So if it takes input A it will go to B, and if it takes input B then it will go to where? It will go to final state. For input B it will go to final state, and as this final state is the final state or the accepting state, so then from Q2 it can also have only a terminal, that is B. So it can also have the terminal B. Okay, and let's see again for state B, that is for Q3. So for Q3 if it receives B then it will go to A, but if it receives A then it will go to final state. So I will also add the A here. And for the final state, what are the things here? So for the final state, if it receives A it will also be in the final state, if it receives B it will also be in the final state, because there is a self loop, and as it is the final state, so it can also receive only A and only B. So this will be our particular regular grammar, where and also how to write the regular grammar. This is the set of production rules. Okay, this is not the whole regular grammar. If I am asked to write the regular grammar of a particular DFA or something, then I have to write the whole tuple. So what were the things in the regular grammar tuple? So first was the set of states. Okay, first was the set of states. So what are the states here? S, A, B, F. Then the next part the next part was what? The next part was set of terminals. So what are the terminals here? A and B. Then there was the starting variable. The starting variable was S, and at the end there is the production rules set. Okay, so set of production rules I have written in like here, and this P is these things. Okay, so I have to write this like P equals to these things, these 4 production rules. So if I am asked to write the regular grammar for anything, so I will have to show it like this. Okay, so this is the set of variables, this is the set of terminals, this is the starting variable, and this is the production rules. So not only the production rules, if I show only the production rules I will not get full marks. For this particular question we will just do the opposite thing. Here a set of production rules are given to us, and we will just form a DFA from it. Okay, so here the starting state is what? The starting state is S. So I will write it like this. I can also give different names, but it will be confusing for you, so I am just giving the same names as the variables. So the starting state is S, and for input symbol A this remains in S. So that means for if any input symbol the state remains in itself, then this is the self loop. So for A it is self looping, and for B it is reaching a new state A. So for B it will reach a new state, that is A. now what are the production rules for A? So for A, it will reach a new state B. From A it will reach a new state B for input symbol A, and for input symbol B it will reach to state S. For which state? From A, if it receives input symbol B, then it will reach to S. So there will be a loop. Okay, and now see for state B, let's see. For state B, if it receives input symbol B, it will come back to A. On input symbol B, it will come back to A, and for input symbol A, it will reach to a state that is F. So this F is the final state. So how do you understand that this is the final state? Because that from B there is a transition AF, also there is a transition small a. Okay, so it can also finish after just reaching F, or it can also have some other new loops and new transitions after reaching F. Okay, so from B, if it have only symbol A, then it will be finished. Okay, so it is accepted. But it may also have some other alphabets in the string, but it can also be finished after having just a single A. So that means the F is the final state. Okay, now let's check what are the transitions from F. So from F, it will reach again the state F for input symbol A. That means there must be a self loop. Okay, see, for it also have A. That means if after reaching A, if it gets another input A, then it can be finished, or it can also have in more other strings also. So that means F is our final state. Okay, and also for input symbol B, it will reach to state B again. So for input symbol B, it will reach to state B again. So this is our particular DFA for this particular set of production rules. Okay, so that's how you draw DFA to production rules, and also the production rules to DFA. Okay, so I hope this, after seeing these examples, this is clear now. So now let's again see. Now we will just convert the regular language to regular grammar. Okay, or regular expression to regular grammar. So here is a regular expression, a star b, a plus b whole star. So I will convert it to regular grammar. So see, a star b. So first we are seeing a self loop. Okay, so a star means what? It means any combination of a. So it can generate anything like a b, only b. For if there is only b, then this a star's value is null. If there is one a before b, then this a star value is one single a. If for this string there are two a's for this a star. Okay, so this means there can be a null also from the initial state. There can be null also, or from the initial state there can be a self loop for a. Okay, so this is the start state. So there must be a null. Null means what? We are just reaching the next state without receiving anything. So I will just give b. Okay, so from a, from starting state, it can also have b, because after receiving the b, we are getting to the final state. Okay, so I will come to this later. First we will just do the self loop. So you already know for a there must be a self loop in the initial state. So from s there is a self loop for initial state, because okay, so because like after receiving 3 a's, it will also remain in the starting state s. Okay, so this part of the production rule, I think this is understood. This s to as means a self loop for a in the state s. Okay, I will just similarly write the DFA along with it. Okay, there is a self loop for a in the state s. This means this. After that, now see, let's check what are the next possibilities. So if this particular a becomes null, it can also become null, because star or clean closure means null also. So this b now can only be the only string here. So this b can be the only string for. So see, if this can become null, this also can become null. So only b is accepted in our language. So only b is also accepted. So to make it only b, that means what? Only after receiving as input symbol b from the initial state, it will reach to the final state. Okay, it will reach to the final state. So for that to make, I will have to make the final state as after receiving b. So after receiving b, it will reaching the final state. Okay, after receiving b, it will reaching the final state. And if it is the final state we already know, then I will have to just write the terminal value also. So after receiving B, it will go to the final state, and as F is the final part, then I will have to write the only terminal part also. Okay, so if there is suppose there is null, or there are a number of things, we don't care about that now. Okay, we have handled this A star part in only this production rule. Now we will just see for this part. So if this part after B there is nothing, then this production rule will come. Okay, from this part, if this value is null, then this production rule will do our job. Okay, suppose there is the string is A star B, so then for A star this production rule is done its job, and for this B this production rule is doing its job. Okay, but if we need to have some value after B also, for that we will need this production rule. Okay, so after B it is reaching to another state, and for that state I will having this particular, I will deal with this particular A plus B whole star thing. So for B it is reaching another state F. Now see for F, because F is the final state we already know. Okay, because why? Because if this is null, then it is also accepted. So that means F is not particularly must need or something. Okay, but if it is required for the grammar. So F, now we are dealing with F. So for this thing we already know that these things can become null. So there must be a loop for both A and both B also. Okay, so see for A star there was a loop for A only, but for A plus B whole star the loop can be for A and the loop can be for B. So from F there can be a loop AF and there can be a loop BF. So from F I am giving a loop for both A and B. Okay, and as F is the final state, so it can be only just A and B, so I will have to write the terminals only also. Okay, so this is the grammar we have created from this particular regular expression. So regular expression was what? A star B, A plus B whole star. So this A star part is dealt with in this particular production rule from S to AS, and this B part, only this B part, if there is no suppose if there is no A plus B whole star value. Okay, so when there can be no value, when this value is null. So if this value is null, then this B part particularly is done with this production rule from S to B. Okay, so S to B, and if this part have any value, then this value is done or is dealt with in another set, because after getting just B we will reaching another state, that is the final state, because only terminal values are allowed only when there for this terminal value it is reaching to the final state. So B is allowed when only for B it is reaching the final state, and I will have to write the production rules for the final state as well. So for the final state I will deal with A plus B whole star, this thing. So A plus B whole star means what? There must be a self loop for both A and B. Okay, so if it receives A it will also reach the final state, or if it receives B it will also reach the final state, and if it reaches final state for a particular terminal, then I will have to write the terminals also. So this is the production rules set we are going to deal. And if I need to write the grammar, I will write it like this. Okay, see what are the states or variables S and F. Now what are the terminals? Terminals were A and B, starting variable S, and production rule. Production rule was this. Okay, suppose there is another question. Okay, so suppose for this particular regular expression I am just making up new examples to let you guys see. So for this particular example, let's suppose the S is our starting variable again. So again see, for 0 and 1 there is a loop. Okay, because this can also be null or this can also be any value of 0 or 1. So there must be a loop if there is a star. So understand this first, there must be a loop if there is a star, or to be more particularly for many cases there must be a self loop. Okay, so for the self loop will be for what? For both 0 and 1. So I can only write one terminal value for a particular production rule. So I will just write 0s and I will pipe it with 1s. Okay, so for this means for if it is state S receives 0, it will remain in state S, or if it receives input symbol 1, it will remain in state S. Okay, so there is a loop for both 0 and 1. and for there can also be a new transition, that is for input symbol 1 it can also go to a new state. So I will write the new state's value as A. Okay, and this is not the final state because there are other input symbols after that, so A is not the final state. Okay, so there is no need to write only terminal part. So I will just equivalently draw the states here so that you can understand. So AC is our state, starting state, and there is a loop, self loop for both 0 and 1, and also for input symbol 1 it is going to a new state, that is state A. Okay, now it is reaching state A, and after receiving value 1, and after receiving value 1, what value should it accept? After receiving value 1 it should accept a new value 0. So for from the state A, if it receives a new value 0, then it will be reaching where? Suppose a new state B. So after receiving value 0 it will be reaching a new state B. Okay, and C, if this value is null, because it is a clean closure, so it can also be null. So if this value is null, then after receiving 0 the string must be accepted. So after receiving 0 the string must be accepted. Okay, the string must be accepted after receiving 0. This means that this B state is our final state. Okay, this B state is our final state, and if it is a final state, then I will have to write the only non-terminal part. Okay, so this 0 part will also be here, and now it is done for this particular state. Okay, and now which state I am left with, or which variable, that is for B. So I will now have to write this for B. So if this value is null, then this is dealt with in this particular production rules. But if this value is not null, then I will have to do it from this particular value to a new state. Okay, so see, from the I'll explain it again from the beginning, but first now deal with this part. So again, what are we doing in this part? We are having another self loop for both 0 and 1. Okay, so for both 0 and 1 there will be self loops, and that as B is our final state, so these these terminals will also be here. So this is our production rule set for this particular regular expression, and this is our DFA. Sorry, there must be a self loop for both 0 and 1. Now this is our DFA, and so just ignore the DFA now. This is our how to make the production rules or the regular grammar from the regular expression. Okay, so again let's see, there is a self loop for both 0 and 1. This term means that, so I am dealing with the self loop for 0 and 1 in this part. Okay, and so I know that the starting state is not the final state because it is not reaching the final state after receiving just 0 and 1. So then I will not write the terminal values here. Now it is reaching to a new state for accepting value 1. Okay, so for dealing with this particular one, I have written this production rule. Okay, so after receiving 1 it will go to a new state, and I know already that this new state is not final state. How do you know that? Because after, if this new state was the final state, then after receiving this one it must be accepted, but after receiving 1 it needed to be accept another 0. So this means that this A is not the final state. So now I will run or now I will write the production rules for this A. Okay, or for the part after the 1. So for this part, this part from 0 plus 1 whole star to 1, this part the production rule is done in particularly this production rule sets, but for the rest of the part it is now written in here. Okay, so see, from state A, if it receives input symbol 0, it will reach to another new state. So for input symbol 0 it will reach to another new state B, and see, if this value becomes null, then after receiving this 0 only it will be accepted, the string will be accepted. So this means that the state we are reaching after receiving input symbol 0, this will be the final state. So if this state B is final, then I will have to write the terminal part also. So this is done. Okay, so up to this part it is done. Now only part left is now this 0 plus 1 whole star part. Okay, so if the value of this 0 plus 1 whole star is null, then it will be dealt with in this particular production rule, that is A2 0. Okay, so A2 receives 0 and then it is done. But if there is something after that, then this will be dealt with this B state. Okay, so for that I have written this 0 to B. So this state is or this particular part of the regular expression is expressed as B here. Okay, and I will have to write the production rules from B also now. So for B there is what? There is a self loop again for 0 and 1. So I have written the self loop from 0 to 0B and 1B, and as B is our final step, we already know, then we will have to write the terminals also. Okay, and this is our DFA. So hope you understand how to convert a regular expression to a grammar, and a grammar to DFA, grammar to regular expression. So I hope this is clear now.